Okay, so this next part is about arc length. And arc length is defined as, arc length is defined as the distance along an arc measured in linear units. Now basically what the circumference is it measures the distance around the whole circle. Arc length just measures part of that distance. So if I was going to put in a diagram on it, okay, so if this was my diagram, and I had a center A again, okay, if I have some segment going from the center to the edge to the circle, obviously that's my radius, let's call that intersection point B. And I had another one intersecting somewhere else on my circle, let's call that point C. The arc length would be this distance right here, let's call that M, okay? Now, of course, the distance from A to C and the distance from A to B, that's my radius, so I can label that R, okay? So arc length is a fraction or a portion of the circumference, and there is a formula for that, okay? L, which is the arc length, is equal to 2 pi r. I wonder where 2 pi r came from. Oh, right, the circumference formula. Times a fraction of all of the degrees in a circle, so we're going to call it m, the measurement, the angle measure, over 360 degrees, because there's 360 degrees in a circle. So I'm using the angle measure that's being created. So this measure right here and this measure right here are the same, okay? I'm using that angle measure, and I'm using the formula for circumference to find the arc length. So let's do an example. Find each arc length. In terms of pi, and rounded to the nearest hundredth. Okay, I'm going to actually move this one down here. So I'm going to go ahead and draw the diagrams and the questions, and then you pause the video and copy, and then we'll do the work together. So arc length, GH, and watch how I draw my diagram. I'm going to put a arc, just like that. Okay, so that says arc length of arc GH. And here is my diagram. So take a second and copy that down. For number 2, arc length, and here's the diagram. So take a second and copy down both of those diagrams so that way we can do the work together. So I know that the formula is L equals 2 pi r m over 360. Okay, now that m represents the angle measure, which I forgot to give you on this example. I'm so sorry. it's 40 degrees. Okay. So L, which is what we're looking for, equals 2 pi. My radius is 6. M is 40 divided by 360. So again, we're going to give two answers. One of them is going to be in terms of pi. One of them is going to be the rounded answer. So I'm going to multiply all of the numerical values that are not pi together. And that ends up giving me 4/3. Bring down my pi, meters. That's it. Or if I don't want to give it in terms of pi, because it says also to the nearest hundredth, I just type all of that straight into my calculator, and I end up with L is approximately 4.19 meters. And that's how you find arc length. Not too bad. It's just a formula. You substitute it in and you solve. For the next one, again, L equals 2 pi r m over 360. So L equals 2 pi. My radius is 8. My m is 134 over 360. So if I'm going to leave it in terms of pi, I'm going to do 2 times 8 times 134 over 360, which gives me 268 over 45, Bring my pi down. And of course, this time it's going to be centimeters. Now, if I'm going to write it in terms of decimals using my nearest hundredth, and you just type all of that in, you get 18.71 centimeters. And that's how you find arc length. Not too bad at all. Again, feel free to email if you have any questions, and I'll happily answer your questions for you.